All right, so we're going to finish off with part 3 of combining functions algebraically. So this is going to be a little bit of a different example because we're going to be dividing. So when you're dividing two functions, you need to be aware that you may have some non-permissible values here. And you should be quite familiar with the phrase non-permissible values by now. But in case you forgot, they're values of x or any variable that don't make the make the equation invalid. Okay, so it makes it undefined. All right, so here's my first example here. We're given two different functions and we want to find h of x. This time if h of x is given by g of x over f of x. So we are essentially finding a quotient here. We're going to be dividing, okay? So just fill in what we need here. So g of x is represented by this function here, x squared plus 5x plus 4, okay? And we're going to be dividing by the expression x plus 1. Okay, so we have a rational expression here. Notice that we do have a non-permissible value here. So remember, my non-permissible values occur when the denominator is equal to 0. So x plus 1 is equal to 0. That means x cannot be -1. So that's my NPV. NPV is equal to -1 so far. Okay? So we want to see if we can actually go ahead and keep simplifying this expression. We have x squared plus 5x on the top here. Let's see if we can go ahead and factor it using PSA. So PSA, here, my product is going to be 4, my sum is going to be 5, and it looks like this is factorable. My two numbers as a result are going to be 1 and 4. So if I try and factor the top here, I'm going to get x plus 1 times x plus 4. Okay, and this is going to be all over x plus 1. Okay, so you may recognize already that we have a common factor on the top and the bottom here. That common factor is going to be x plus 1. So if we cancel it out, we're going to get a final expression for h of x. It's going to be equal to x plus 4. And don't forget to state your non-permissible values. X plus 4, where x cannot be equal to -1, because that's a non-permissible value there. Okay, so just be aware that when you are dividing functions, you may have some non-permissible values, and so it's really important to state those. Let's take a look at one more example here where you're dividing. If f of x is equal to x squared minus 49, and g of x is equal to x plus 4, you want to determine the simplified form of h of x if h of x is the quotient of these two functions. All right, so let's start with what we need here. H of x is equal to g of x over f of x. Okay, so let's fill in what we have. G of x is given by this expression, x plus 7. Okay, f of x is given by this expression, x squared minus 49. Okay, from here, since we are dividing by a polynomial, it's really important to once again state what your NPVs are. Okay, so the NPVs for any rational function occurs when your denominator, which is x squared minus 49, is equal to 0. So when we solve for x here, we're going to get x squared is equal to positive 49. When I take the square root, I have to consider the fact that it's the plus or minus square root. Therefore, I'm going to get two non-permissible values. One at 7 and a second at -7. So these are my non-permissible values. So make sure you're stating those when you are dividing functions. Let's carry on with the simplification. You're going to take a look at the top and the bottom now. Are these expressions factorable? Well, x plus 7, you can't really do much with that, but take a look at the bottom here. Now, you may try to, you might assume that you can't PSA it, therefore it's not factorable. But this is a special polynomial that we definitely taught you back in grade 10 and obviously in 20-1. This is a difference of squares, okay? So if you factor a difference of squares, you're going to get this, x plus 7 and x minus 7. Okay, so that's a little bit of a review there. So you check, can we simplify? Are there any common factors on the top and on the bottom? Well, yes, we do. We have a common factor, and that is x plus 7. So if I cancel those out, I'm going to be left with 1 on the top and x minus 7 on the bottom. So this is my h of x function, but remember you need to state those NPVs, so x cannot be 7 and also x cannot be negative 7. Okay, so that concludes part 3 of combining functions algebraically.